Hello, my dear. It's nice to see you. We have a wonderful lesson, a fantastic lesson. It's about what about the mixture? Let's see. How can you obtain and know the different type of mixture? Yes, I try to breaking down a lot of things. Yes, different things. It's not important what these things, but it's very important to know when I add them to each other, we can obtain the mixture. The mixture, different particles, as you see, added to each other with any ratio. So, has a different shape. These shapes back to its structure may be homogeneous or non-homogeneous. Matter made of two or more substances mixed together with any ratio. See, water, it's a mixture. Yes, it has a water, it has a salt. The soil is a mixture because it have different particles. This mud, it's a mixture of bacteria, microbes, anything. Oh, salad, I like it. It's a mixture. Salad is very important. Fruit salad, vegetable salad, both of them mixture. Great to say. Mixture can be classified into two. Yes, homogeneity may be homogeneous mixture or non-homogeneous mixture. Let's see what is the difference between them. For this table, we have a point of comparison and definitions. At the beginning, homogeneous. It's a mixture in which the solute molecules regularly distributed in the solvent part, regularly, one after one, step by step. But non-homogeneous, it's a mixture in which solute molecules are irregularly distributed by in the solvent part, anything non-homogeneous particles. This is not only. Also, we have the solute molecules and its characteristics. Yeah, for the first, look at this. Solute for the homogeneous cannot be distinguished by naked eye. It's impossible to see it by naked eye as a seawater. And it characterized by has same appearance in all its parts. But non-homogeneous, it will be what? Can be distinguished, yeah, because it has a big particles, can be seen, distinguished by naked eye. And it has contrast in its properties at its pores. Wonderful to differentiate between homogeneous and non-homogeneous mixture. Wonderful, my dear. Now, what about solution? Solution, it's a mixture. Yes, we know that homogeneous in composition and properties. Now, try to find what is a different solution, maybe true solution. Look at this. I want to make a tri-solution. I have alum, sugar, and different materials also for the salts. Try to prepare true solution in the common salts. Get the first one. This is the salt. Yeah, and I try to add it to the water. Stir them. Preparation of true solution by sugar. Also, get the sugar, add it to the water, stir them. You have true solution. Yeah, for the third alum, yeah, added to the water also by fixed amount, no, any amount, and try to stir it. Now, alum solution. Ask, what is the difference between the first, second, and third? I add indicator to tell me what happened. We can differentiate between them. Difficult, but let's see what is the common between them. For the first tube, When we add the common salt to the water, has no color, cannot be seen by naked eye. Sugar, by the same, can't be seen by naked eye. Also, alum can't be seen by naked eye. Now, can you see any particle inside? Sure, we can't do that. But I can filter them. I can separate them. Let's see filtration of the common salt. Get a filter paper, put it in the funnel and put it in the tube. Now try to add each one alone. For the first, the solution will move fast and fast and fast. This is a solution. Now there is nothing the same color. Filtered, difficult for filtration. Also, if you want to make a pea, it means a sugary solution. No color can be seen, cannot be filtered, also difficult to be seen. For the third one, alum, yes, cannot be seen. Then, true solution, difficult for filtration. Now, my dear, can I differ the other one? Yeah, identify the colloidal solution, collide. Yeah, we know it. Get a starch, we know it well. Egg, albumin, and try to make a solution by them. Preparation. Preparation of the colloidal solution. For the first, get some of the starch, add it to the water. Also, try to stir them. This stirring is very important to know what happened. This is the heating of solution. When you add starch to the water, where is the color? Yes, the color is changing. What about transparency? It's not transparent. Why? Because it has a big particle. This particle, yeah, make it no color, cloudy color. Here we have a cloudy color. Do you think this has happened for albumin? Sure, because both of them, yes, colloidal solution. Filtration also. Get a funnel tube and I try to add starchy water. Yeah, water and starch, colloidal solution. It moves drop and drop, slow and slow. But in filter paper, there is a particle inside. Yes. Now, my dear, there is different. Yes, there is big difference. What about stability? It's stable, not stable. There is no stability here. Good to say, colloidal solution can be filtered because it has large particles. These large particles help us to see what happened. Now, preparation of albumin. Albumin, we know it well. We said albumin as a starch. Get albumin of the egg, add it to the water, some of the amount of the water inside. Also try to stir them to see what happened. It's wonderful. At the top of beaker, you see the particles of albumin. It has a big particles. Now, I try to add drops of the acid inside this albumin of the water and see. Do you think will it change? Transparency. What about them? Yeah, it's not clear. It is not completely transparent. Why it's not transparent now? It's not transparent. Directly we say it's a colloidal solution. My dear, don't forget, big particles, it's difficult to separate them, but we can do by filtration. Same funnel, paper, and try to add the albumin to this filter paper and see what happens. When you add drop by drop, yeah, it's as a starch. We know both are similar because both are colloidal solution. What about suspension? I don't know it. I think you know it well. If you get it chalk in water, we can do that. Easy. Get chalk powder. When you get some of chalk powder and add it to the water and try to stir them. Ask yourself, chalk will stir? I don't think so. Look at strawberries. Yeah, it's a big particles. Can be filtered? Sure, but take care. When you look at this, you can see cloudy. What happened? Yes, this solution, it's not cladle, not true, but suspension solution. Add the filter paper and try to separate between them. When you add chalk and water, do you think what happened now? Yes, the water will fall down and the precipitate of the chalk will stay in the funnel. Now, it's a very big particles. What about stability? It's stable? I don't think so. So, which one more stable now? True, cladle, or suspension solution? Answer by yourself and catch the important one. All of them are important. You can do that also by sand, by soil, by different thing. What about the soil in water? Soil in water? I don't know what it's a type. Get a soil, add it to the water, and try to stir them. Transparency. Yeah, transparent or no? I don't think it's not transparent. Yeah, it's a soil. The color is changed to the brown, the color of the soil. What is the kind? We can say suspension, cladle, or true solution. Find the answer and don't forget to send it me in my mail. Filtration can be filtered? Answer by yourself. This is question for you. Get funnel, filter paper, add a soily water and soil, and see what happened. The water start to pass drop after drop. Also, there is a lot of particles stay in the filter paper. Do you think what this type about? Try to catch it. Sandy water, we saw a lot of them. Get a sand, add it to the water, stir them. Now, look at transparency. What is the transparent now? Add it to the tube and look at and see what happened. It's not transparent. Ask yourself, true, cladle, or suspension solution? Catch it, my lover. It's easy to catch all of them. Filtration? Do it by yourself. Funnel, filter paper, and add the solution of the sand and water. When you add a solution, take what happened in filter paper. This is the water is passed, but the sand is not passed. It's large particles. Oh my God, we can say a stability of sand and salt. Stable or not stable? I am waiting you to answer in my email. Don't forget that. Now, this is the difference between the three types of solution. Do you think this is the only types of solution? No, my dear. Try to see and compare between all types. Fly to the other one. Look, my dear, solution need a solvent. Do you think what's the meaning of solvent? Solvent here, it means water. It means substance which is found with great amount in the solution. We know it. It's water. Without water, there is no solution. Another one. Yes, you remember double exchange here? Yes, sodium carbonate and so on. This is an phenolphthalein also. Yeah, this is water. We need it's a solvent. Another one, solute. Yeah, we know it. Solute, it means a salt. It means a sugar. It means a starch. Different material that can be dissolved in the water as the substance which is found with the smaller amount in the solution. Large amount solvent, small amount it means solute. Wonderful to catch them. Both are solution. Now we have a water, litmus paper, and plate. This is fire, this is a match to know what happened for this reaction. My dear, as a beginning, I try to turn on the fire, this special one for the lab. It's ready for the work now. After that, I get this holder and fix a piece of magnesium in this holder and I try to burn it. Take care and ask what happens if you burn them. Look, it's a fast reaction because we have a much amount of the heat. Now, it changed this substance into powder. I try to collect this powder and add drops of what? Yes, drops of water or acid to see what happened. Look at this reaction. It changed from solid substance to solution. It's easy. Look, if you add a drop for two litmus paper, red and blue, the blue stay blue and red change it into blue. It means now you have a solution of magnesium hydroxide. Take care. How can I know? By changing the color of litmus paper. This it means basic oxide. Oxides of the metal, basic in the nature. When the metal oxide dissolved in the water, the metal ion react with the water in the form. Now, unsaturated solution. Do you know what's the meaning of unsaturated? Yes, unsaturated, it means solution in which additional amount of the solute can be dissolvent at the certain temperature. So, what happened? Add more and more and more of salt, more of acids, more of sugar, more of anything. This is unsaturated. For the other, you have here two solutions, water and sand. For the other one, copper sulfate solution. Also, we have milk solution. Yes, we know the milk is a solution. I want to know what happened inside the water with the sand. Is filtered or not filtered? We can answer when you stir and try to shake it many times and put it for the filter paper and see what happened. Now add soil with the water, sand with water, and look from the down. The particles move and move and move. What about pure water? Large or not large now? Yes, it's a few amount because the big particles of this sand stay in filter paper. The filtration of the sand grains are larger. Take care and concentrate. Now, I try to exchange it by the other one. Do you think all of them stay? No, we conclude water with the sand is a solution. It's easily separated. Why? Because non-homogeneous. What about the copper sulfate now? Get a copper sulfate, add it to the filter paper, drop by drop. Do you think what happened inside? That is we'll see. Look at this. When you add the solution of CuSO4, copper sulfate, look, large amount of copper sulfate is passed. Do you think what about filtration? Yes, it's a homogeneous solution. Yes, saturated, has a lot of salt dissolved inside the water. No filtration at all. Cannot be filtered. This it means you have true solution. Saturated has a lot of salts, a lot of ions that be dissolved in. Do you think this is only? Sure not. What about to go to the milk? Look at this, pure and homogeneous. We know why it's true. Not filtered. Small particles, small ions cannot be seen by naked eye. It's easy to know copper sulfate homogeneous, no filters, no inside it. Now, what about the milk? Some one after one start to pass, not fast, not slow. This it means the other type of solution. It's great to say solution has two factors. What and what? Solute and solvent. Fly to the other one. Now, look. The solvent has the ability of dissolving another, yes, amount of solute. Also, saturated solution, it means it's a solution in which no additional amount of the solute can be dissolved without a change in temperature. Impossible to be more. Why? Because there is no temperature. Saturated solution. Look at this. When I say that, the solvent has not the ability of dissolving another amount of solute. It's wonderful. Another one, supersaturated solution. Supersaturated, yes, we know it. We need a large amount of solute. It's solution which allows the dissolution of an additional amount of solute with increase of temperature. It's great. Here we have a main factor, increase in temperature. Wonderful to ask and answer saturated, unsaturated, and supersaturated. Fly to the other one. Do you think what this about? The amount of solute greater than in the case of saturated. Look, acid in the human. Oh, we ask, we have acid? Sure, we have acid, but what about them? Acid secreted by the stomach help in digestion of protein. What is acid? I don't know it. No, you know it. It's hydrochloric acid. Acid and food. Food has acid? Yeah, guava has acid. Orange, I like it, has acid. What about tomatoes? Has acid, rich in vitamin C. We know ascorbic acid. Wonderful to know that. Citric acid, I like it. We need a lot of the acid in our food. Another one. During physical exercise, we have lactic acid. It's produced in the muscles. If you feel tired, this it means you have a lot of lactic acid. Try to stand, try to move to make a lactic acid away. Great and wonderful. Another one. Yes, yeah, we know this acid. This is the hydrochloric acid. How do you know? When I add the zinc, a piece of zinc, a piece of the metal, any metal active than the hydrogen in acid, start to make a reaction. Now, inside our body we have acid. In the world we have acid, and everywhere we have acid. So acid is very important for the reaction, maybe inside our stomach, maybe inside the food, maybe in the world. Catch the acid, my lover, and fly to the other one. This green leaves, yeah, we like it. Green leaves of vegetables contain folic acid, which is necessary for the proper growth of the cell. To grow, get a lot of fresh food, fresh vegetables, green leaves. We like to do that. It's an apple. I like, but it has a part is eaten. Do you think what happened for this apple? We like to see this apple. It's delicious and it has a iron. It has a lot of the salt. This salt is very important for us. Do you think what happened if we leave it for a long time? Oh, it becomes a brown. You see the part which changes to brown? The other part become more dark. The dark increase and increase and increase, and the other part becomes white. Do you think why? It's not well now. We don't like it. It has an iron, we know, but it becomes black now, dark now, brown now. Do you think why? Because it becomes rotten. Away of the rotten food, we don't like to eat apple. Let's fly to the other one. For this, orange and lemon, we know they contain citric acid. Citric acid is very important, which is used in preservation of the substance in the food industry. We put it in different materials to preserve food. It's great to know that. Another one, vitamin C in the orange protect us from the common cold. Get vitamin C. We are in winter now, and don't forget that. Another, yes, a watermelon. But what happened for the watermelon? Watermelon is not delicious. It becomes, steers, it becomes black, it has a white spots. It has a mold, a lot of the mold. Do you think it's delicious now? I don't think so. Leave the watermelon and fly to the other one. I need a good food. Look for this. Acids in industry. Yes, nitric acid, for example, and phosphoric acid are used in manufacture of fertilizers, which is important for the soil. Also, if you get sulfuric acid, is used in, car batteries. Also, fiber manufacture. It's easy to use. It is very important to them. What about oil distillation? All of them from the batteries and fiber oil from sulfuric acid. I like this acid. Another one, economic importance of the some common bases. Yes, as an acid, fly to the base. Do you think what is a base? Yes, we remember bases is used in medicine. Yeah, bases and the medicine as magnesium hydroxide, MgOH2, is used in manufacture of antacid. Yeah, medicine is used to neutralize the stomach acidity. If you have any trouble in the stomach, fly to magnesium hydroxide, MgOH2. Great base. Other one, bases in industry as calcium hydroxide, CaOH2, is used in what? Used in, manufacture of cement. You know the cement? Yeah, for the buildings. Also, water treatment, reducing the soil acidity. If you add it to the water and soil, make it well. It's suitable for cultivation. It's wonderful, this piece. Another one. What about the economic importance of some common salt? Yes, we studied acid, we studied bases. Let's catch the salt. Look at this man. Yes, it's a food. It's good now. We are ready to get this food. It has a lot of salt. I am hungry now. But what happened? 3 days passed. Oh my God, the food isn't changing. It's not well. It's eaten by bacteria and fungi. I don't like it now. It becomes dirty and dirty. Day after day, after 7 days, it becomes bad. We don't like to eat this. Where is the minerals? It's away. The food is away. No, we don't like it. Fly to the other one. Yes, my dear. Salts in human is very important. Do you think why? If you have a calcium and magnesium salts are the main component of your bone. Not bone only, bones and teeth. This is very dangerous, very important. Also, phosphorus. Yes, phosphor salts is very important to contribute of the formation of the tissues to be good tissue. Yeah, my dear. Look. If you get a sodium and potassium, yeah, we know it. They are very important for responsible for the transfer of nerve impulses. Nerve impulses catch sodium well, catch potassium well, you will be well. Wonderful. We arrive to the end. My dear students, be careful, concentrate, and try to read the lesson well and answer the homework. I am in waiting. Don't be late. See you soon. Goodbye.